The following is a presentation on risk-based asset renewal, specifically for the water industry. I think we all know that the industry is faced with a challenge regarding its aging infrastructure. And I think we also know that it's not feasible in the short term to try to replace or renew the entire system based on its design life. So what is risk-based renewal? Risk-based renewal really is just a decision-making process supporting year-over-year cash flow optimization based on the premise that some assets may have a useful life exceeding their design life. Some assets may be more suited to a fail and fix strategy rather than scheduled replacement. Some assets may require accelerated replacement due to their monetized criticality. And some assets may be more suited to just rehabilitation versus outright. So the big picture might look like this for your utility. This green line below represents normal O&M costs, steadily increasing over time. Risk costs, on the other hand, are the costs of unplanned maintenance and repairs and direct and indirect consequences of failure. And it's this difference between the risk cost line and the normal O&M cost, which is the benefit, potential, or opportunity. So this is what's captured through a replacement or rehabilitation project. And this is what risk-based renewal strategies are all about. It's all about managing the risk cost curve. One of the opportunities in this approach is to be able to look at individual projects from a monetized risk benefit to cost ratio standpoint. So as risk is reduced through project implementation, you can compare that to the cost, and that gives you a benefit cost ratio. You can also look at existing resources that are being spent right now to hold the risk curve down and determine project effectiveness from that standpoint. Another opportunity from a risk standpoint is to be able to look at the time of replacement or renewal strictly based on risk and not necessarily design life. So design life may show an early renewal activity, whereas looking at it from a risk threshold standpoint, we might be looking at a later activity. Another opportunity is regarding cash flow optimization for projects, for specifically replacement projects, but could be renewal projects too, rehabilitation projects. This is showing the risk curve again, laid on top of the NPV of a renewal project. And if you add up these two curves over time, the minimal point, where the sum is minimal, will be the optimal point or the best time to actually make that investment. So this is going to be the least cash out of pocket at this point in time. It's not necessarily where these lines cross. It's where the sum of the marginal cost or risk cost plus the NPV are added together and are minimum. So to make this happen, well, first you need a risk model, which we have, and that is fed data that's particular to the utility, and some of the data might be public data too that's helpful in the risk calculations. We can also use industry averages, industry break rates, and things like that. The risk model then generates risk results, and these results are prioritized and grouped. Then we get a sense of the kind of projects that we can implement to minimize risk if that's something that needs to be done. And then the results out of here drive a short-term plan. The risk model and data, the data that can be accepted in the model can be geospatial data, databases, spreadsheets. So it tends to be quite disparate and of different forms and formats. Once processed through the risk model, we end up with results regarding different kinds of threats, like degradation threats, which is corrosion, cracking, threats that vary over time, time-independent threats that don't necessarily vary over time, such as sabotage and third party. Those would be your likelihoods or your probabilities, and we multiply those times the direct financial, societal, and environmental costs to get a full picture of risk, and compare these against the asset owner risk threshold. So on this drawing here, the red shows up as areas of the system that may need short-term attention because they exceed certain thresholds. But the thresholds may not necessarily be just the design life. If you lay this out now on a time scale, we can see that the orange bars are showing replacement based just on design life. Whereas blue gives us a different view or a different story, because this is based on risk criteria. This is going to be based on the likelihood and consequence of failure. This information can then be put on a map or not, and then you can see logistically what areas can be collected together to make up project areas. And then within these project areas, we can then use the same risk model to compare different kinds of projects. There's different types of rehabilitations and different types of replacements that can be done. The point is to find out what's the most effective. And that's what this is showing here, just comparing different kinds of projects and their benefit cost over time, as well as comparison to their asset value. So through this process, we find it's a useful approach because it can optimize annual cash flow, ensuring resources are directed to highest areas of risk. It supports the selection of best projects to reduce risk over a certain time period, and it supports sound financial planning. This has been a quick introduction on risk-based asset renewal. If you have any questions at all, my contact information is in the email I sent you, or you can simply just reach out to our website or email expert@expertinfrasolutions.com. Thanks for listening.